Hello guys, welcome to our Python tutorial part 4. This is our Shivastava, and in this video we are going to work with the stars data. So it is just today's video is just depending on the exoplanets near stars. So what is a exoplanet? So exoplanet is a planet which is near a star. So by recording the brightness how it's covering, if it's covering, then there is a exoplanet, the brightness between the satellite, and a satellite record this by which is thrown by NASA, and this data is thoroughly and based by NASA, and this is not having any null values, and the prediction in it is all right. So just moving forward, it also tells us that how many days that planet takes to revolve that star, and like that. Before moving to the data, we will first import the module. So we will import pandas as pd. So it is pandas, but we are importing as pd because it's a huge name, and while writing the data and using it, so it would be a huge name. Instead of that, we can just use pd, and in this it works a lot. So first we'll use matplotlib dot py plot. Okay. So pie plot is a function which helps us to create the line plot and the scatter plot. So we will just check that how many days that stars takes us to revolve the star, and there is an exoplanet there or not. No. So, and we'll import numpy also, numpy, and like pandas only, we'll import numpy as np, and after importing it, we would just make exo test df as a variable in which we are going to store this whole data. So pd dot read c in pandas, a function is there which is pd read csv, and read csv helps us to read the data, and it shows in a particular manner. So yeah, and after this we are just going to print the data and check whether it's printing right or not. So this data is very important, and this data is also given in this description of the video. And after that, we are just going to use check the data, what the type of it is. So first, we will use the shape. First, we will see the shape of the data. So first, we'll write the name exo df. In this name, we had saved it. So, and sorry, and by this first we are going to use t, means it's a very good word, means transpose, and transpose helps us to transpose the data. So it just change rows to columns and columns to rows. In this there are 570 rows and 3198 columns, and in this 3198 rows and 570 columns. So it just change it. And for one more thing which you need to know, that what is this flux value. This is the fluctuation of the star, that how it's moving. So it has all been recorded by the stars, and a totally of 3198 fluctuation are recorded by the satellite, and so that it would be so accurate. And now we will use the type function. So type function is used beneath this. So type, like this, we will use the type function. It will tell us that what it is. So yeah, it's telling it is a data frame from pandas. Okay, so now after removing this, after using this type, we will also use is null is very good function. It helps us to know that there is any empty values in the data or not. So is null, and it's the bracket means the function, and after is null we will put no, first we will check with is null also, and then we will put some also. So by the name only you can get that is null or no. So it is null, false, it is not null. is it null? If it is, it would be written to true, then there would be an empty value in this place. And now how you will check from the data, 4 means 5 to 5 6 4. So with the help of sum, it would be telling us in numbers. So and after this we will you will also able to use isna instead of isnal. If you don't remember its name, so you can use isna. Both are same, and the both function the same. And yeah, last video I had not explained how to remove the exact location. So if you want to remove the data flux 8, fluctuation of 8, so what you will write is just you will put this, and uh, first you will take an inverted comma, as it is a string value, flux 8. Exact, the name should be exact, otherwise it would not tell us. So flux is written in capital letters. So just a second. Flux and dot 8, I guess. Dot 8. So it would be removing or retrieving all the data of flux 8. So see, from starting the zero indexing position 6.98. 6.98. So yeah, you can see zero indexing position and 6.98 means here. Okay, so like this we remove, with the help of this we can also remove label 9, fluctuation 9 and all. So and rows also we can remove. And uh, now we will use a shape. So what the function which I use now is known as indexing. And yeah, shape, 570 rows and 3198 column, and size will tell us the total count, that how many blocks are there, total blocks. So it would be multiplying both of them, and 1822860 is the total strength of the data frame. And now we will uh, uh, im- now we'll use a shape only. But in shape also you can use index if you want only the rows of the data. So 0, so 0 will give us 570 only, so 570 rows. And if you will use 1, so you will be telling that how why we are using 1 instead of 0 instead of 1. So in programming all things starts with 0. So and like that, after one more is left, which is describe is the main function used by is also one of the main function used by a programmer, because it helps us to know the count of the data, and it helps us to know the standard deviation of the data, minimum and maximum of the data, mean of the data, and 25, 50, and 75%. Now 25, 50, and 75% is new. So what is 25%? 25% is the data which is between the smallest value of the data frame and between the median value of the data frame. And the 50% is no, you can say it's the median value of the data frame. And the 75% is between the largest value and the median values of the data frame. And maximum and minimum you would be knowing, but then also maximum is the highest value of the data, and minimum is the lowest value of the data. And mean and count how many total blocks are there, 570, 570, and 570. And creating graph. So at the end we will be creating two graph. One would be scatter graph, and one would be plot. So we will be using the data of star 0. So we would be predicting the fluctuation of star 0. So what we would be actually doing is that we would take star 0, and we would we would retrieve all the fluctuation of it. So it would be showing us that there is an exoplanet nearby or not. So we will use the PLT, means pyplot. We had imported now matplotlib dot pyplot as PLT. So like that only, PLT dot figure and fixed size. So figure is the keyword, or you can say it's a function in matplotlib pyplot, and fixa is the keyword in figure. So you have to take care that in both of them you have to give small round brackets, and figure, you should not use any square bracket, because square bracket is used in list or in iloc uh, or in while indexing something like in shape we had done. And in this, with the help of figure, what we will do exactly, we will give the width and the height of the data, so 20, and the height should always be one fourth of the data, so it would be getting us a cleaner view. So I would putting as 6, you can also put as 5 and 7, so it's your wish. And now plt dot no, first we will make a um, star zero data, so we will name as star zero only. And star zero we are going to use the data exert test only, and with the help of exert test we are going to retrieve the fluctuation of the data. So to uh, to retrieve all the fluctuation of the data, first we have to write the data frame, means this data, not this, uh, this data frame name, okay. Yeah, so this data frame is equal to exotest So exotest and exotest we need to retrieve the all the flux values of star zero. So we would name as zero, no, not name as, but we will use the iloc. Iloc is helps us to index or retrieve the values, but in column, you can say column views. So what it does, this is the star zero, okay. So in star zero these are the flux values. So now it would take all from zero, from start, label is just used, the is given by the NASA date only, so this is not considered in the data. The counting starts from here. So this means 0, this means 1, 2, 3, 4, 5, 6, 7, 8, and so what we are using is that now the one and all. So the one what we had used, zero is the zero. Zero is what we need to remove, and from zero we have to remove one and all. So one and all. So it would be retrieving all the flux value. So after this, we would just use plt dot plot means the line plot of the data is equals to, so in python we call line plot as plot. So after that we are going to give it np dot arrange. So we have to take a care that arrange it is, not arrange. Arrange means arrange from 1 2 3 1 9 8. So a range of this number unit, and that star, okay, sorry, star zero. And after this we are just going to grid, we are just going to add up the grid of the data, and we are going to show it to everyone. And now show function is very important. Without writing show, it will not show you anything. So just a second, yeah. So as I told you, it is a line plot, and we can say that there is an exoplanet nearby. Why? Because the fluctuation are very high, and in some star you will be able to see that the fluctuation are very low. It's like this only in one line only, zero position only they move about the position. But you can also say that the exoplanet nearby this is very small, or this planet is only very small, because the fluctuation done by it are very less, so the brightness would be also very less. And now we will use a scatter chart. It is also helps us to know the value well, but it is more good than line plot, because line plot is easy understandable, but in scatter plot you can see the data shown, and the line grid lines are very understandable, because if you will see that within 200, so within 200 you can see that there is no movement, so you can say the movements are very high. So like that the equations are made by the scientists, And thank you for watching my video. Please subscribe and like my video. And I'm going to and be safe, and always keep trying to see my videos. Thank you.